So looking at these examples, all these series from example 8, we are going to take a little bit of a deeper look at each of them. Previously, we talked about absolute convergence. So as a quick reminder, a series A sub n, sometimes my phone likes to go off when I say the word series. A series A sub n converges absolutely if, when you examine the series of the absolute value of A sub n, if that converges. So over here, we start off with a series, and if we slap absolute value bars on it, effectively this alternating component just vanishes because all of them become positive 1. So we're left over with just the positive part of the sequence, which is 1 over n. This is the harmonic series. It diverges. So this particular question, example 8, did not ask us to go any further than that. Just, does it converge absolutely, yes or no? This does not converge absolutely. So now the question is, does it converge at all? And the answer for this particular series is yes. It converges by the alternating series test. So although this series in and of itself, as written, converges by the alternating series test, there is a sense in which its convergence is somewhat weaker or not as desirable as a series that converges absolutely. So the fact that it, when you make all the terms positive, that forces the series, in this case, to diverge, that means the series converges conditionally. So this implies it converges conditionally. So a series that converges conditionally is a series that converges in and of itself, so by the alternating series test, but it diverges when you examine the absolute value of the series term. So as a quick little thing here, what does this mean? Conditional convergence means this series converges, but this series, absolute A sub n, diverges. That's what it means for a series to be conditionally convergent. So the second series here, let's just give these some numbers here. Number 1, number 2, number 3, and, or nope, 4 and number 5 last, okay? So series number 2, this series converges absolutely. Its convergence isn't conditional upon whether or not we choose to examine the absolute values. So converges conditionally. Number 3, this series converges absolutely. We went through that. So a series either diverges, converges absolutely, or conditionally converges. Those are the 3 convergence classes. So it's 3 choices: diverges, converges absolutely, or converges conditionally. Number 4, this series, when we take a look at the absolute values of it, it creates a series that diverges. So it definitely does not converge absolutely. Now the question for this series becomes, does it converge at all? And since this is an alternating series, well, actually, is it an alternating series? Well, let's take a closer look. This negative is just there. All the terms are negative. So this is actually not an alternating series. So we can't use the alternating series test. does this series converge? The answer is no. Why? Well, for the same reason that we used to show that the series of the absolute values diverge. It's the same exact thing. The limit as n goes to infinity of negative 3n squared over 4 plus n squared equals negative 3, which is not 0. So by the divergence theorem, or the divergence test, excuse me, this series diverges. So the series just diverges. All right, number 5. We found that this series converged absolutely. So if it converges absolutely, there's nothing else to check. It's only when it doesn't converge absolutely that we had to do more work. Does it just diverge all the time, or does it converge conditionally? So that's the main difference here about those are the main things to know about absolute and conditional convergence.